because this is a section where a lot of students make mistakes because they don't understand. If you want to find the derivative of composite functions, use the chain rule. It's not a product rule, it's not a quotient rule. It's only used for one function inside of another function. In order to do that, the inside and the outside functions of composite functions. So to remember that the notation for composite functions is f of g of x with a little o and then a g of x. In our calculus book, we're not going to have the clue that it's a composite function by using this notation. H of x equals sine squared x. And we're going to have to know that that outside part in this function, what's the outside function? We'll call it f of x here. The outside function is whatever being squared, right? Something's because our outside function doesn't have an x inside of it. It's got a whole function inside of it. So we use the letter u. U is our outside function. I know it looks like fu, right? So that would be with an x, but f of u would just be u squared. So the out is something being squared, and we'll call it the letter u because it represents a whole function. We're not going to use x. And u represents the inside function, so use the inside, f of u is the outside. We have to be able to distinguish those before we can even use the chain rule. So here are some other examples. The inside be on this one. I hope you notice it's x minus 7. And the outside, we'll call it u to the 5th. So this would be u, and this is u to the 5th. We could write f of u equals u to the 5th if we want, but we're not going to need to get that technical. We'll just be writing u equals, and then we'll be writing the outside function here. So what's the inside of cosecant 2x? Well, the inside is just the 2x, and the outside is cosecant of that 2x. Here the inside is 4 plus x, and the outside is the square root of that 4 plus x. We're taking the derivative of this piece. We're going to want to write it like this. Here, we could do a quotient rule here, sure, yep, but you could also think of it as a composite function, the x plus 1, and the outside could be 1 over u. Now this one I would probably just do as a quotient rule, if you'd like to, and then you could also write it like this. So then here, if you write it like this and this, you'll have to do a quotient this and this, then we'd just have to do a chain rule. Here we would just have to do the quotient rule. So your choice there on that one. But these you have to use. I guess on this one, we could multiply it out. If you really hated using the chain rule, you could multiply this one out, but that's a lot of extra work. And the chain, okay, now that I've got you completely scared, let's look at some non-composite functions. This one you could rewrite as x to the negative 2. This one is x minus 7 squared, and then we've got an inside and an outside. So some functions can be written as functions. This is a quotient rule, so it's not a composite function. All right, here it is, the chain rule. And I know it looks times the derivative of the inside. So here's the notation. That was our outside function, f prime of u, and then u. So those are just the derivatives of each piece. So the derivative of the outside, and then u is the inside, so there's the derivative of the inside. And you just multiply them together. It only works if you're taking the derivative of a composite function. So let's do some examples. First, you identify the inside and the outside functions. The inside is 3x minus 2x squared. All that quantity to the 3rd power is the 3x minus 2x squared. The derivative of that would be 3 minus 4x. Is that u, which is the inside, to the 3rd power. The derivative of that outside is 3u squared. Then all we do is take them and multiply. The inside is 3 minus 4x, and the derivative of the outside is 3u squared. But this u wasn't in the original, so always remember to replace u with what it's equal to, 2x squared. So our derivative of the whole function is 3 minus 4x times the quantity, and the something that's squared is u which was our original outside function. So you see how this is the derivative of the inside, and all we did, this u was the same, and we just took the power out in front and subtracted 1 from the exponent. A common error is to put it inside of the outside function. You're not going to do that. We're just multiplying the two together. Multiply the derivative of the inside times the derivative of the outside. The inside should be in part of your answer. And then all we have to do is simplify that if we can. The book probably would leave this factored and just put it in a better order like this. So keep it factored. All right, let's try some more. Okay, we have g of t equals -7 all over 2t minus 3 to the second power. Right now it looks like a quotient rule, plus this is an inside function and this is the outside function. So we have a chain rule inside of a quotient rule. Not going to be fun. So let's rewrite it like this. 2t minus 3 to the -2. If you bring that up, then we have a constant times a chain rule. Okay, because that's our constant function. So let's just make sure at the end here, oh, notice the order. It doesn't matter what order you multiply them in. You could multiply the derivative of the outside times the derivative of the inside, or like on the previous screen, we did the derivative of the inside times the derivative of the outside. Multiplication's commutative, so you can do whatever. All right, so our derivative of g is going to be -7 times, remember constants, you can just write them and then multiply times the derivative of the answer. So we're just going to focus on taking the derivative of this part right here in the chain rule. So I wrote that down there so I remember to multiply by that -7 out there. Okay. So u is 2t minus 3, that's the inside function, and the outside is u to the -2. Derivative of u is 2, derivative of the outside. Put the power out in front, subtract 1 from the exponent. So we have -2u to the -3rd, which is -2 over u to the 3rd. So we're going to multiply -7 times the derivative of the outside, which is -2 over u to the 3rd, times the derivative of the inside, which is 2. And then remember to back substitute, because our final answer has to be in the same variable that we started with. So g prime of t is 28 over u to the 3rd, and u was 2t minus 3. Okay? Obviously, we could have done this a different way. We could have multiplied this out and then just done a quotient rule. But what if this were to the 12th power? Then we would not want to have to do that. This one, we'd have a product rule and a chain rule together. There's no way around it. We're going to have to do a product rule and a chain rule together. So let's rewrite this power, the square root as a power. So here's my product rule, these two pieces, and then this part is the chain rule. So you can set up either one first. I'm just going to set up the chain rule first. So the inside of the chain rule is 1 minus x squared, and the outside of the chain rule is u to the 1/2. The derivative of the inside is -2x, and the derivative of the outside is 1/2 x, or 1/2 u to the -1/2. Multiplying those two together, we have -2x times 1/2, and then u to the -2, -1/2 brings that down there. The 2's cancel, so we have -x over the square root of u, which was 1 minus x squared. So we have this -x over the square root of 1 minus x squared. That's just the derivative of this purple piece right here. Okay? So remember, when we do the product rule, we do u and v. Okay, don't get the u's and v's mixed up with the u and the f of u. U is x squared, and v is this whole piece, 1 minus x squared to the 1/2. So we've already done the derivative of v, or v prime, if you want to call it that. We've done that. It's right here. So this is v prime. We've got -x over the square root of 1 minus x squared. The derivative of this is 2x. So now remember the product rule. U times the derivative of v. So it's x squared times negative x over the square root of 1 minus x squared. I don't need both of those in there. Plus, and then we're going to go this way, 2x times 1 minus x squared to the 1/2. So those two, we multiply those together, and we've got negative x cubed over the square root of 1 minus x squared plus 2x times the square root of 1 minus x squared. Of course, the book's going to get a common denominator, so let's multiply this by the square root of 1 minus x squared on the top and the bottom. So the right fraction becomes 2x times 1 minus x squared, because the square root times the square root is just itself. And then it's all going to have the same denominator. And then here we have negative x cubed. So distribute that, of course. The book's just going to keep marching along, making sure that you get it as simple as possible. And combine your terms, so we got negative 3x to the third plus 2x. And maybe they factor out an x, maybe they don't. Just leave it however they leave it. On a test that I give you, if it's not multiple choice, you can just leave it however you want. As long as you've got the final, like you've got it simplified. So you could even leave it like this, you know, as long as you've got everything plugged in and you have no u's left. So you can't leave a u in it if it's an x problem. All right? So that's a product rule in a chain rule. Homework, page 137, 7 to 33 odd.